Hi, this is Jeff Campbell from Materion. In this episode of In Our Element, I'm going to talk about the coefficient of thermal expansion. The coefficient of thermal expansion, often abbreviated CTE, provides a measure of how much a material expands or shrinks when heated or cooled. Thermal expansion explains why pipes sometimes tick when the boiler turns on. The units for CTE are expressed as strain, usually in parts per million, per degree Fahrenheit or Celsius. The focus here is linear coefficient of thermal expansion, but note that the area and volume will also undergo thermal expansion because thermal strain expands in all three directions. CTE values are many times displayed as a single value, but the CTE is a function of temperature. CTE data can be presented as a table with average CTE values over temperature range, or it can be presented as a curve showing the instantaneous values, also called alpha values, over a temperature range. To determine the CTE over a temperature range, simply average the alpha values at the low and high temperatures. This will give you the average CTE over the temperature range. To determine the thermal expansion and thermal strain, you will need to know the start and end temperature and the length of the part. The strain will be the product of the average CTE over the temperature range times the number of degrees it will increase or decrease times the length of the part. In our heating tube example, a 120-inch length of copper tubing with a 9.4 times 10 to the minus 6 CTE heating from 68 to 150 Fahrenheit would grow about 92 thousandths, or about the width of 2 dimes. The copper tube rubbing against wood as it grows is usually the source of the ticking. The thermal strain is dependent on the temperature change, so it should be considered if the operating temperature is much hotter, like in a furnace, or colder, like at high altitudes or space, than the assembly temperature, which is usually room temperature. The strain is dependent on the length, so the CTE should also be considered if you are designing something very large. Expansion joints are designed into bridges so that expansion between winter and summer does not lead to buckling. If the application has 2 or more different materials operating over a broad temperature range, you might check to make sure the CTE for the material will not cause excessive stress or bowing as the part changes temperature. There are applications that take advantage of the difference in CTE. Bimetallic sensors and switches make use of 2 materials with different thermal expansion rates bonded together. Since the 2 materials expand at different rates, the composite will curve towards the less expanded side on heat up or more contracted side on cool down. Keeping the thermal expansion coefficient in mind when designing or selecting materials can help maximize performance or avoid problems. Information is available on the web to help you choose the material that is best suited for your particular expansion problem. Thanks for joining me for another edition of In Our Element. For ongoing industry updates, connect with me on LinkedIn.